Okay, let's start the next part. So if you solving circle permutation, problem. If there is, there is a basic condition of adjacent, we use it. We have to think we must be adjacent or must not adjacent, and then it is just like it is just not normal problem. It's basic plus there's condition. Like in this problem. And in this case, solving the permutation, just normal permutation, you have to list your sequence in your head, in your brain. Sequence. So first and last, and before and after. Just before and after. You have to think it. You cannot just list it and then and you find that your answer is wrong, and you have to think first and then you have to think something. Like in this circle permutation, you have to, in this before, you have to think criteria. I said that the first perspective is not good in solving these problems, and I'll talk that in here, because I think almost always I'll use perspective 2, because in this before I will choose things and I will think it is criteria, and then before you choose criteria, and then you have to think left things, other things. So in here, example problem, EX, and there is 6 people, A, B, C, D, E, and F. Okay, there is 6 people, and okay, first condition, A and B have to adjacent, have to. They have to stay closer, I don't know. And in this case, I'll write circle, and I'll just write A, B, C, D, E, F, A, B, C, D. Okay, I don't know, E, F, yes. In this circle table, A, B have two adjacent, bundle up. Okay, let's make it one part, A, B. And we can just think, okay, there is 5 blocks, 1, 2, 3, 4, 5, okay. But if this is circle permutation, so we can write 4 factorial, because if we write 5 factorial, it overlaps, we can rotate it. This 4 factorial, we can just get it from both of perspective 1 or perspective 2. Just, so there is 5 blocks we can think, and 4 factorial, but this A, B can swap their places, so we can write 2 factorial, and that's the answer. So we first, before we choose criteria A, B, or perspective 1, so we used it, and then we list left these 5 people, and so you have to think before and after. And example, second example, I think this is most hardest part. You know that we used O and we will use X. A, B must not adjacent. Oh, I think that's more harder. Nope, we can't. I don't know. But they can't stay closer. In this case, we use that insert. Insert, do you remember? Insert. We first list C, D, E, F. C, D, E, F, and then we insert A and B in this 4 sector. But before these 4 people have to be listed. So we choose criteria, we choose criteria C, and then we list these 3 people. Okay, 3 factorial, and then we use just normal permutation. So in these 4 cases, and this part we can say this is circle permutation. But after this, after listing this C, D, E, F, it is we choose the criteria C, D, E, F, and we can think it is just normal permutation, just to line up. Just we list this A, B on the just one line. So we can just write it for P2 like this. So and after we listed left things. And last example, AB. I don't know their but they have to be on opposite. For example, there is circle table, and there's A, and there have to be on opposite side of me. Opposite side of A. So we can say that there is 6 people can sit. If A goes in here, B have to be on here, and there is 6 seat, but 4 seats are blank. So just C, D, E, F goes on here. But if I use this criteria before, I will check this A for criteria, and we can say A, B. Okay, and if we just choose the A and B's seat is defined, so we can just multiply 1, and then we can just think these 4 people. But A and B becomes criteria, and then we can say that these 4 places are not circle permutation, it is just a normal permutation. So we can write 4 factorial, and that's the answer. So if we think this part as first perspective, we can't imagine. But if we think it just criteria, okay, pick one A and B, and that's we can make just normal permutation. Okay, this 4 factorial, and we can make the answer. So I think second perspective is more useful. And then I think in here if same things are included on circle permutation, in my 수능, yeah, in my SAT, I think there's no kind of these things in the test. But yeah, I learned this, so I will write for you. First, there is 4, I think just 4 balls, yeah, ball. A, B, C. Okay, A, B, C. This case, we can't use circle permutation. We have to list all of them and think it. You have to list it, and there is no formal formula. Yeah, just write factorial or kind of something. You have to write, and okay, I know that. You have to all list it first. We can say that A goes here, and B goes here, and C. And then there can be A, C, B. And then A, B, C. But it is same of A, C, B. It is just rotated and it is same. And we can know that the number of cases is 3. You have to just write it, yeah. And then there is A, B, B. Yeah, A, B, B. There's more little, yeah. A, B, B. And A, B, B. Only 2 cases, yeah. And number 3. There's A, B, B, C. A, B, B, C. And as you know that there's C, yeah, on here. There's 2A and 2B, but there's only 1 C, so I think I can use it as a criteria, and we can use it. So I will just write C on the top of the circle, and if there is A on here, this is 5, so I will write circle 1, 2, 3, 4, 5. Okay, and A can be here, and there's BB, or A can be here, A, BB, or A can be here, A, BB. So we can say that, okay, 1, 2, 3, A can go here, or here, or here. Okay, I can write the 3. There's 3 cases. And then, but if there's no A on here, so we can write C, because we picked the criteria as C, so we can write there's something on here, A, something, okay. A can be here, and A can be here, but A cannot be here because we already counted it in this case. So A can be here and here. Okay, 2 cases. And lastly, A can be here. And only A can be only here. It cannot be here and here, because in this, if I put A on here, it is okay. Then we already counted it, so A only can be here, and that's 1. And we can say that this is just case. Number of cases is 6. There is informal formula. Yeah. I think we will not use it very much. Yeah, there is like a permutation and same things in there. N minus 1 factorial P. There is formula like this. It looks like quite reasonable, yeah. But we can only use this when GCD is 1, and I'll talk about this. if I use this formula on this first case, okay, there is 4 things. Okay, 4 minus 1, 3 factorial, and there is 2 same a's, so I will write 2 factorial. Okay, 3. Okay, that's same, and there is 3 number. Yeah, case 3 a b b c. Okay, there is 5 but minus 1. Okay, that's 4 factorial, and there is only 2, so I will write it 2 factorial, and it goes for 24 divided by 4. Okay, there is 6. Okay, that's same. But if I use this formula on here, a b b c. Okay, 3 factorial. Oh, there is 2. You can find that it's decimal 1.5. Yeah, it's not same 2. It's because the GCD is not 1, it's 2. So it is because there is criteria. If there is 1, it means that there is 1 character, 1 letter, is different. Because of that, we can use that as a criteria, and then we can think just divide it with PQR, factorial. But in this case, there is no criteria to use. It is 2 and it is 2. We can't use it. If there is 1C and 1C on here, we can use it as criteria. So in my case, I think you can just count it by yourself. Your brain, your smart brain is smart, like pencil and paper. But you can know this formula if you want. This time we'll talk about polyhedron permutation. Okay, let's start. Okay, there's box. Before, there's box. There is cube. We can write number 1 to 6, and I can like the length of the side is A, B, C. Okay, let's go. First, there is box, and length A, B, C, and if first case, if A, B all equals, it is same. Use criteria. If I wrote number 1 on top, and it's criteria number 1, okay, I just write 1 and multiply. There is opposite side of this number 1. There can be 2, 3, 4, 5, 6. There can be 5 characters, 5 letters, 5 numbers can be there. So we can write number 5. Just I'll like opposite, and then if we watch this box on the top, we can find that there is number 1, and there is 4 places, and we can think that as okay, I will use circle permutation, so we can just write 3 factorial, and that's the answer. Okay, case 2, second case. Okay, for example, there is very So as in this box, we can say F is not equal to B. Yeah, all different. Yeah, I have to write A is not same with C in is not equal. Just you can understand that A and B and C and all are all different. Yeah, in this case you can say that same. Write number 1 on here. Okay, 1. And choose the other side. Okay, I will choose other side. There can be 5 numbers. And then if we watch this, watch this. There is 4 places. There's number 1. In this case, I think use perspective number 1. Yeah. If we flip one time, we can find that it goes with 2. So we can just write 4 factorial divided by 2. And that's the answer. I used circle, permutation, perspective number 1. Okay, and then let's talk about third case, and it is same, but okay, I'll write. Okay, it has long side. Okay, A, B, C, and A equals to B, but it is not equals to C. In this case, we can use just we can use the criteria, but in this case, you can use this side and this side, and use combination. So see, there is 6 letters, 6 numbers, so 6 combination 2, and then like this first thing, there is 4 numbers are listed with the circle permutation. So in this case, you can write like first case just 3. So in this case, if I use combination, we can solve it more easily. Okay, and that's the polyhedron permutation.